right, so we are looking at learning objective 6, which is to write names and formulas for ionic compounds. So again, these are compounds that contain a metal or a polyatomic ion. All right, so let's get to work. Writing or naming ionic compounds, the cation always comes first. So the cation or the positive ion always comes first. The negative ion always comes last. So the first thing that you need to do when you're writing names from formulas is to identify the cation. It's either going to be a type of metal or it's going to be a polyatomic ion. So the only polyatomic ion that you have that is positive is ammonia, which we'll talk about a little bit later. So if it's a metal, is in groups 1, 2, aluminum, zinc, or silver, you do not have to signify the charge. So group 1, group 2, aluminum, zinc, or silver, you do not have to identify the charges. These guys have set charges. So group 1 always has a +1 charge. Group 2 always has a +2 charge. Okay, so group 1 +1, group 2 +2, aluminum is 3+, zinc is 2+, silver is 1+. So you do not have to signify charges for these. If the metal is a transition metal, we have to signify the charge. Now, the way we signify the charge is based on the anion. So it's based on the anion charge and the number of the anions. Okay, so based on the anion charge and the number of anions. If the cation is a polyatomic, that means that it is NH4+, because that's the only cation that is positive on the polyatomic ion sheet. You just write ammonium. So if it starts with NH4, it's ammonium. Okay. The second thing that you need to do is to identify the anion. So if the anion is a nonmetal, this would be considered a binary compound. We talked about this a little earlier. So a binary compound is if it's got a nonmetal in it, you're going to change the suffix of the nonmetal to IDE. Okay, so anytime you have a binary compound, the second element's name changes to IDE at the end at the suffix. If the anion is a polyatomic ion, the name does not change. Okay. So then I can look at these guys, right? So I've got a lot of examples right here. So I have Na2. Na is sodium. If you didn't know that, you could look on the periodic table. So looking for sodium, Na is right here. So this is sodium. So I've got sodium, and that's a metal. So I'm going to write sodium. Sodium is a group 1 metal, so I don't have to do anything special to it. Okay. I would have to do something special to a transition metal. And then I have O, which is oxygen. And this guy is going to change its ending to IDE. So this is sodium oxide. Okay. I'm going to leave some of these. I'm going to leave some of these for you to actually work on your own. I'm going to show you like the 3 types. and try and show you how to get your charge on your cation for your transition metal. So let's look at this one. I've got MnSO4. So Mn, now a lot of times students get confused between Mn and Mg. So Mg is magnesium, Mn is my it's my manganese, Mg is my mag. Okay, so magnesium, manganese. So Mn is my man. All right, so manganese here is a part of the transition metal. So it's in groups 3 through 12. So this is a transition metal. So this is a T metal. That means I'm going to have to signify my charge on this guy. So I've got manganese. And I'm going to put a parentheses there just so I know that I've got to write the actual charge down in Roman numeral. And then I have this guy. So now I have 3 elements here. So I'm going to need to go to my reference sheet on the back of my periodic table and find whatever it is I have, right? So I've got SO4. So I'm going to look for SO4. So SO4. So SO4. Oh, there it is right there. So sulfate is my name. Now, I also kind of want to look at this charge here. So it's -2. So I have sulfate. So that sulfate has a -2 charge. So if I've got 2, -2, my charge on manganese is a +4. Okay, because my charges have to balance out to equal to 0. So manganese 1V sulfate. Okay. Always look at the charge. So sometimes it works out and you get the number that you are supposed to have if you just look at the number that is beside the anion, but sometimes it doesn't work that way. So like this one doesn't work that way. This one also doesn't work that way. So I have SN3, PO4, 2. Okay. So this one, because I have a number here, I'm going to assume that this is my charge on the SN. Okay. So because I've got a number there, I can assume that's the charge on that one. For these other ones, so for this one, so for manganese 4 sulfate and copper, this copper oxide compound, I can't actually do that. This one, I've got NH4. Oh, if it's NH4, it's ammonium. And it's bromide. Or bromine. This guy's bromine. Which goes to bromide. Okay. So you can practice with the other compounds that are there. I've left the rest of those blank. Writing formulas from names. The first step is to identify the charge of the cation as a +1, +2+, 3+, etc. Okay. Roman numeral gives the charge of the transition metal. Okay. So identify the charge of the anion as 1 minus, 2 minus, 3 minus, etc. And then you're going to balance the charges. So then the charge, or the absolute value of the charge of the cation, becomes the subscript of the anion. And the charge of the anion becomes the subscript of the cation. If you have a polyatomic that needs more than one place, you're going to place it in parentheses. So reducing subscripts if necessary. This is only for ionic. So if I've got like Cu2, O2, and then this is coming down and this is coming down, then I have Cu2, O2. I'm going to reduce this to CuO. Okay. So I have aluminum. So I know aluminum is Al. I also know that it's got a 3+ charge. And then I have iodide. Well, that's iodine. So because it's iodine, then I know it's I. And this has a -1 charge. So now I'm going to kind of erase these positive and negative. I'm not going to pay attention to those. And I'm going to circle them, and I'm going to bring them down to the aluminum. The 1 goes down to the aluminum. The 3 goes down to the iodine. So then I know I have Al-I-3. All right, so iron, know that iron is Fe. This is signifying the charge on iron, so it's signifying that it's got a 3+ charge. Now, anytime I see those Roman numerals, I know that it's the positive number value. Okay, so then dichromate. Well, I don't know what that is. So one of the things that you want to do, if I've got an ATE or ITE, ATE or ITE comes from the polyatomic ion sheet. Also, if I can't find one on the periodic table, most likely it comes from this polyatomic ion sheet. So dichromate is Cr2O7. So again, we do not change this formula. It's Cr2O7. And it has a 2- charge. So Cr2O7. So Cr2O7. And it's got a 2- charge. So again, I'm going to ignore the plus and the minus. Okay, and then I'm going to switch. The 3 goes to the chromate. I need to put the chromate in parentheses because I'm bringing a number down. And the 2 goes to the Fe. So this is Fe2 Cr2O7 3. Okay, so I'm going to leave you at the rest of these to kind of do on your own as practice. So this was learning objective 6, which was to write names and formulas for ionic compounds.